Hello there, this is an Algebra 2 video. It is Chapter 5, Section 2, and today we will be talking about dividing polynomials. And so first off, we have an example where they would like for us to simplify this polynomial. And the easiest way to do this is to actually break it down into individual fractions. And so we'll do that. So what I mean by that is we're going to take 6x to the fourth y cubed divided by 3xy. Basically what's happening here is you're dividing all of these terms by 3xy. So we're going to do that individually. 12x cubed y squared divided by 3xy. And then 18x squared y divided by 3xy. And then when we do that, we can actually simplify each fraction individually and make it a little bit easier for us to deal with. So 6 divided by 3 is 2. This x will cancel with one of the x's on top, leaving you with a 3 instead of a 4. So now it's 2x cubed. And then the same thing will happen with this y. We'll take away one of these y's, and you'll have a y squared instead of a y cubed. So that term reduces to 2x cubed y squared. In a similar fashion, we can do 12 divided by 3, which is 4. And then this x will cancel with one of the ones on top, making it an x squared. And this y will cancel with one of the ones on top, making it a y to the first. So that term reduces to 4x squared y. And then lastly, 18 divided by 3 is 6. And this x cancels with one of those x's. And both of these y's cancel out. And all you have left is minus 6x. So this would be your final simplified answer. Remember that you can't combine terms unless they have the same variable and the same degree. So x cubed and x squared don't combine, and so there you go. So in a similar fashion, I'd like for you to try to do it yourself, number one. And then we will go on to actual division. And before I do that, I want to kind of give you an example. A lot of us learned how to do, obviously we learned how to do long division a very, very long time ago. It might be something that we don't remember necessarily every single step, but if you want to know how to do polynomial division, you're going to have to remember the steps for long division. So I'm going to kind of do them side by side here. This is an example of 15 divided by 2. We know that 2 doesn't go into 15 evenly, and I'm sure that most of you probably already know what the answer is, but I want to do this example so that I can show you just the process of how long division works. If you remember, we figure out how many times 2 goes into 15 evenly, which I'm sure we could all agree is 7. And then we multiply 2 times 7 and get 14. And then we subtract. And then 15 minus 14 is 1, and that's what we call our remainder. So when we say 15 divided by 2, we know that the answer is 7 with the remainder of 1, is one way of saying that. Another way of saying that is that 15 divided by 2 is the same thing as 7.5. And a lot of you will recall that you have this whole little thing about how do you write a mixed number as an improper fraction. 2 times 7 is 14. Plus 1 is 15 over 2. This is a mixed number. But basically, that mixed number is to take how many times it went in evenly, which is what we call the quotient, and then add the remainder divided by what you divided by. So the remainder divided by the dividend. So anywho, I just kind of wanted to remind you of how that works. So basically 7.5 literally means 7 1/2. Most of you, if I had asked you what 15 divided by 2 was, would automatically 7.5 because 1/2 is 0.5. Just want to remind you of that as we come over here and do long division. There's obviously a couple of things that are a little bit different, but for the most part it's the exact same thing as that. So the first thing is, how do I know how many times x minus 5 goes in evenly to x squared? That's the first part. Well, in this case, in the case of a polynomial, what you want to do is always take the leading term, so that's x squared, and divide it by the leading term of the divisor, which is x. If you can reduce this fraction, which is just x, that's what you divide by. That's the 7 over there. That's the first thing you put here is x. Okay, now at this point it becomes the same as that. Notice that over here, after we put the 7 here, we multiplied 2 times 7. So we have to multiply x times x minus 5. So x times x is x squared, and x times negative 5 is negative 5x. Okay? The next thing we have to do, which a lot of times students forget when we're doing it with polynomials, but you don't forget over here. After I put my product here, 2 times 7 is 14, I have to subtract. So that's what I'm going to do next. I'm going to subtract these. It's very important that you're not afraid to subtract. So x squared minus x squared is 0. And 3x minus a negative 5x is actually 3x plus 5x, which is 8x. And then you can bring down the rest of the number, or in this case, the rest of the polynomial. And we do it all over again. Again, we need to figure out what should we put up here. Well, you take the leading term and divide it by the leading term of this guy. The x's will cancel and you'll get just 8. So that means we're going to put a positive 8 over here. And then we'll do the process all over again. We're going to go 8 times x is 8x. 8 times negative 5 is negative 40. And then we're going to subtract. So 8x minus 8x is 0. And negative 40 minus a negative 40 is the same thing as negative 40 plus 40. And you basically get a 0 remainder. So what this tells us is that x minus 5 goes into x squared plus 3x minus 40, x plus 8 times. The other thing that it tells us is that x minus 5 is a factor of x squared plus 3x minus 40. In other words, if I had asked you earlier if 2 was a factor of 15, you would have all said no. And the reason why it's not a factor of 15 is because nothing times 2 will actually give you 15. No integer times 2 will give you 15. If I told you, if I asked you if 3 was a factor of 15, you would say yes, because 3 times 5 is 15. The other side of that is that when I say is 3 a factor of 15, it's also true that when I divide 15 by 3, 3 goes in evenly. I have a 0 remainder. And when I divide by 2, it doesn't go in evenly because I have a remainder. And so this idea of having a remainder tells you a lot. It tells you when you have a remainder that it's not a factor, that it doesn't go in evenly. So right now, the fact that I got a 0 remainder tells me that x minus 5 does divide evenly into this polynomial right here. And so if I wanted to, I could factor x squared plus 3x minus 40 as x minus 5 times x plus 8. But for now, as far as what is the answer to this problem, the answer is x plus 8. And if I had gotten a remainder, if I didn't get a remainder, but if I had a remainder, I would have written down x plus 8 and then plus the remainder over the divisor, just like we did with the 1/2. So if, for example, my remainder was 3, then I would say x plus 8 plus 3 over x minus 5, because that's what I divided by. All right, so just so that you know and so that you're aware of that. So now I'd like for you to try these 2 examples, and then we're going to move on to another example. This is actually a multiple choice question. It's one of those questions that you'll see on a standardized test like SATs or those kinds of things. And basically I want to, but first off, show you why this is in the section. A squared plus 7a minus 11 divided by 3 minus 8 to the negative 1 power. We know from the previous lesson that when you have a negative exponent, you have to reciprocate it. So basically, I could rewrite this as a squared plus 7a minus 11 over 3 minus a to the positive 1 power. And now it looks like a division problem, where I'm taking a squared plus 7a minus 11 and dividing it by 3 minus a. So at this point, we need to do our division to figure out. So what I'm going to do is I'm going to write it as an actual division problem, put my 3 minus a over here. And I want to put it in the right order. So first I'm going to take this off. I just wanted to show you how that works. And then instead of writing 3 minus a, I'm going to write negative a plus 3. And if you remember earlier, we said that the first thing we want to do is take our a squared, which is our leading term here, and divide it by negative a. And when I do that, I'm going to get negative a on top. So the negative is still going to stay there, and this a will cancel with one of those a's, leaving you just a to the 1 power. So I get negative a. So this needs to be negative a, and the negative a times negative a is positive a squared, and negative a times 3 is negative 3a. And then I subtract, and a squared minus a squared is 0. 7a minus negative 3a is 7a plus 3a, which is 10a. And then if I do this process again, I take 10a and divide it by negative a. The a's will cancel, so I'll get negative 10. So up here I'm going to put negative 10. Negative 10 times negative a is positive 10a. Negative 10 times positive 3 is negative 30. Subtract. 10a minus 10a is 0. And negative 11 minus negative 30 is negative 11 plus 30, which will give you 19. And at that point, there's no longer an a here, so you can't go any further. So now you'll see that we do have a remainder. Our remainder is 19. So our answer is going to be negative a minus 10 plus 19 over the divisor, which is 3 minus a. So negative a minus 10 plus 19 divided by the divisor, which is 3 minus a. So C would be our answer for example 3. And now you'll try to do it yourself, number 3, and then we will move on to the next little guy. And the next little guy is something that I think that you'll actually enjoy, and it's something that we call synthetic division. And long division can get kind of, well, long. And so synthetic division actually allows us to do division a lot faster and in a lot less space. So the one thing I do want to warn you about is that when you do synthetic division, you can only use synthetic division when you're dividing by a linear factor. So in the previous examples that we did with long division, and by the way, long division will work no matter what the factor is. If it's a quadratic factor or a cubic factor, it won't matter. The long division will always work. But the synthetic division only works when it's a linear factor. So you're dividing by something that's x to the 1 power. So x minus 4 or 3x minus 2, or as long as it's linear. Okay, so that being said, I'm going to show you how to do it. And with synthetic division, all the space you're going to need is somewhere to put this kind of a elongated L. And what you do is you take the divisor, which is divided by x minus 4, you take that and make it equal 0 and solve for x. So it's really simple to do in this case. You just get a positive 4. So the 4 goes here, outside your little L, your elongated L. And then you want to write down only the coefficients of all of the terms of your polynomial. And if any of the terms are missing, you need to put placeholders, which are zeros. So, and that includes the constant factors. So you have cubic, and then the quadratic, the linear, the constant. So the way I do it is a 3, 2, 1, none. If you have a 5th degree, it's got to be 5, 4, 3, 2, 1, none. So you would need to have a number for each term. Each term is not there. In this case, all of my terms are present. I've got 3, 2, 1, none. So all I have to do is write the coefficient of each term. So 2, negative 13, 26, give yourself some space, and negative 24. So you write down all of the coefficients. Next, you always bring down the first coefficient automatically. That's always going to be the first coefficient. Now it just becomes a multiplication and addition game. So I multiply diagonally and I add vertically. So what I mean by that is 4 times 2 is 8, so this becomes an 8. Now vertically I'm going to add them together. So negative 13 plus 8 is going to be negative 5. And then I multiply. So diagonally I multiply. So 4 times negative 5 is negative 20. But vertically I add. So 26 and negative 20 is going to be positive 6. And then diagonally I multiply. 4 times 6 is 24. And vertically I add. So negative 24 and positive 24 will give me 0. And the last number in your row here is always the remainder. So what this tells me is that this has a 0 remainder. So again, it means that x minus 4 goes evenly into 2x cubed minus 13x squared plus 26x minus 24. Also, it tells me that x minus 4 is a factor of this polynomial because it went in evenly and had a 0 remainder. Okay, but now, what's the answer, right? The answer is how many times it went in evenly. And so now, these numbers, if the last number in the row is the remainder, then the other numbers are actually the answer to the problem. And these are also coefficients. Just like these are the coefficients of the original polynomial, these are now the coefficients of the answer. Okay? And so they're going to be the answer, but you have to keep in mind that it's always the variable, because you need variables, right? The variables are going to begin with 1 degree less than the original problem. So if my original problem was a cubic, it means my answer is going to be a quadratic. So that means that this is going to be a quadratic term. The original was a cubic term. This is 1 degree less, so it's going to be a quadratic term. So my answer is 2x squared, and then from there you just kind of go down the chain. Minus 5x, and then plus 6. This would be the answer to my division problem. 2x squared minus 5x plus 6. So hopefully that made sense. And now I want you to try these 4 examples doing synthetic division. And then we're going to do one last example. And this last example is still synthetic division, but I want to show you a couple of things. We're missing a term. 4, 3, 2, 1, none. There's no constant term here. So I'm going to show you how we need to put a 0 there. And then also we have, instead of just x plus something, there's 3 in front of it. But remember that what I said before still holds. You take your divisor, which is linear, it needs to be linear, make it equal 0, and then solve for x. So we subtract the 1, divide by 3, and so x equals negative 1/3. So when I do my elongated L, instead of having a 4 out here like we did last time, we're going to get negative 1/3. And then we want to put the coefficients of our polynomial, 3, negative 5, 1, 7, and a 0. So it's 4, 3, 2, 1, none. The 3 comes down here, and everything else is the same. So we're going to go 3 times negative 1/3 is negative 1. Negative 5, and again that's diagonally, right? So vertically we add negative 5 and negative 1 is negative 6. And then we multiply negative 6 and negative 1/3 is going to be positive 2. And then 2 and 1 vertically is going to be 3. And then 3 times negative 1/3 is going to be negative 1. Vertically 7 and negative 1 is going to be 6. And then 6 and negative 1/3 is going to be negative 2. And then vertically 0 and negative 2 is negative. So this time I do have a remainder, and my remainder is negative 2. So what that means for us is that this now is our answer, but these are going to be the coefficients of our answer, but 1 degree less than the original. So the original was 3x to the 4th, so this is going to be 3x cubed minus 6x squared plus 3x plus 6. And remember that when we have a remainder, because it's a negative remainder, we're not going to put plus, we're going to go minus 2 divided by your divisor. And our divisor was 3x plus 1. So that is how you would write your answer as a mixed number. You would write how many times it went in evenly plus the remainder divided by the divisor. So this is now our answer for example 5. And so there you go. Now you can try these ones on your own, and once you have completed this do-it-yourself question, you will have completed your notes for this lesson, and I will see you in class, and thank you for watching.